Hello guys, this is Ride On Academia, and today we'll be looking at the equation of a straight line passing through a given point and perpendicular to a given straight line. Okay, in our previous video we looked at equation of a straight line passing through a given point and parallel to a given straight line, but today we are looking at the perpendicular aspect. Okay, how we can find the equation of a straight line when we have a perpendicular line and only one point given. All right. Our formula remains this. By the way, if you've not watched our video on gradients from the first edition, please do well to look at it, okay, so that you can catch up with us where we are now. All right, so this is the format we use for our gradient when we want to determine our equation of a straight line. We have that m is equal to y minus y1 over x minus x1. Okay, this is our formula for determining equation of a straight line. Now, the second thing I want to look at is that when we have perpendicular lines, okay, when we have perpendicular lines, the gradient of the first line, which is our m1, will be equal to the negative inverse of the gradient of the second line. So m1 is equal to the negative inverse of m2. Okay, so this is what it means. But in most textbooks, what you will see is something like this: m1 and asterisk, okay, and then we have m2. What it simply means is that m1 is equal to the negative inverse of m2. All right, the negative inverse of m2. All right, with that we're going to take a question and we'll be solving that quickly. All right, so given that we are asked to determine the equation of a straight line passing through a minus 3 and 4 and perpendicular to the line 2y plus 6 is equal to 7. So we have that the straight line was passing through a point. The point was A. We have minus 3 and 4. Okay, this is our first circumstance according to the line, and we have that it was perpendicular, all right, perpendicular to 2y plus 6x is equal to 7. All right, so these are the two factors relating to this line. This is the point, one of the points it was passing through, and then it was perpendicular to this. Like I said, before we will be able to solve all this, we have to first of all determine our gradients. All right, and then we'll be using this equation to determine our gradient before we can solve further. Okay, so using this equation to determine our gradient, we have 2y plus 6x is equal to 7. Like I said before, if you've been following us from the start of our gradients, I've said that our gradient is equal to the coefficient of our x when our y is subject of the formula. Okay, that's our gradient. So to get our gradient from here, we have to make y subject of the formula. Okay, that's y has to stand alone. So 2y will be equal to, this will become minus 6x plus 7. We have to follow the format y is equal to mx plus c. That's why our x is coming before the constant. Okay, all right, so we have come to this point, but our y is still having a coefficient, but we want y to be subject of the formula. So we divide all through by 2, all right, so we have that our y is equal to minus 3x rather plus 7 over 2. Okay, all right, so with this, from this, like I said, the coefficient of our x is minus 3 when y is subject of the formula, so minus 3 becomes our gradient. Okay, so our m2, which is the line through which the line we are talking about passed through, okay, which is perpendicular to our m2, is equal to minus 3. That is the gradient for our second line. The perpendicular line is minus 3. Now, like I said, our m1 is the negative inverse of m2, right? And now this already, so it will be minus 1 over minus 3. All right, so this and this will cancel to give us what? 1 over 3. Okay, are we together? So this is it, and that's what we'll be using to solve. Now since we have gotten our gradient for M2, we can now bring in this format to get our equation of the straight line we're talking about. Now we have only one point given, so we can label our point as x1 and y1. Okay, so let's quickly go to our formula. M is equal to y minus y1 over x minus x1. Okay, m, which in this case is 1 over 3, is equal to y minus y1 is 4. All right, and our x1 here is minus 3, so we'll be having minus 3 in brackets. Okay, minus will become plus, so we have 1 over 3 is equal to y minus 4 over x plus 3. Are we together? Alright, so we have that gradient, which is 1 over 3, will be equal to y minus 4 over x plus 3. Okay, the next thing we'll do is to cross multiply, right? Like I said, because of our factor, which is y is equal to mx plus c, it means our y has to come first. So y cross multiplying, y we multiplying by 3, everything here, and then 1 like that. So we have 3 times y will give us 3y, and 3 times minus 4 will give us minus 12, equal to 1 times x will give us x, or 1x as the case may be, and 1 times 3 will give us plus 3. Okay, now we have to collect like terms. Like I said, this format what we are following, meaning y will be standing in, we'll be taking the constant over. So we have 3y is equal to x plus 3. Now when this sign comes over, it becomes plus 12, right? So we have that 3y is equal to x plus 15. So this is equation of the straight line. Okay, when one point was given and it was perpendicular to another given straight line. This is our equation of the straight line. Now we'll be taking one more example. Alright, so for our next example, we are given that our point A is equal to 5 and 10, and then this straight line is also perpendicular to 2y plus 3x is equal to 6. Okay, and we are asked to find the function, the straight line function of this line. Okay, we are given only one point, and we are told that it is perpendicular to this line. All right, so the first thing we are going to do, like we did before, we'll find the gradient using our straight line function. So 2y plus 3x is equal to 6, right? Like I say, our gradient is the coefficient of our x when our y is subject of the formula. So with that, 2y will be equal to 6 minus 3x, or rather, I want our x to be first, so we have minus 3x plus 6. Alright, so when we divide through by 2, divide by 2, divide by 2, our y will be equal to minus 3x over 2 plus 3. Alright, now the coefficient of our x is minus 3 over 2. Therefore, our gradient, which are m2, is equal to minus 3 over 2. But the rule remains that when we have perpendicular lines, m1 is equal to the negative inverse of our m2, right? Alright, so m1 will be equal to minus 1 over minus 3 over 2. Now the beautiful thing about this is you can split here. So it's the same thing. This is the same thing as minus 1 over 1 divided by minus 3 over 2. Okay, minus 1 divided by minus 3 over 2 is the same thing as minus 1 over 1 divided by minus 3 over 2. So you can now spin this and change this sign to multiplication. We'll be having minus 1 over 1 times 2 over minus 3. Okay, that is to be having minus 2 over minus 3. That is 2 over 3. Okay, so I just did this workings to show us what it will be looking like and how we'll be getting our gradient. So our gradient m1 is equal to 2 over 3. Okay, you can see the proof in our bracket. So we'll be using this now to determine our equation. We'll return back to our formula. which is m is equal to y minus y1 over x minus x1, and our m is 2 over 3 is equal to y minus, now like I said, this is x1, since we are leaving 1 point, this is y1. Okay, so this is our y1, y minus 10 over x minus our x1 is 5. So in the same manner, we cross multiply. Our y is coming first to fulfill that formula, y is equal to mx plus c. So in cross multiplying, 3 times y will give us 3y, 3 times minus 10 will give us minus 30. Okay, 2 times x will give us 2x, and 2 times minus 5 will give us minus 10. Alright, so we want our y to stand alone, meaning our constant will be going the other way. So our 3y will be equal to 2x minus 10. Now when minus 30 cross this equal to, it will become plus. So we'll be having plus 30, right? So we'll be having 3y is equal to 2x. Minus 10 plus 30 will give us plus 20. So this is our equation on this line. Alright, so with this we have come to the end of gradient. We have come to the end of equation of a straight line passing through a given point and perpendicular to a given straight line. So please, if this video was helpful to you, like this video, subscribe if you haven't, and